two successive point on the wave. Okay, so you can see lah. Yang sama lah. If you okay. Ataupun the length lah. The length of space over one cycle from the beginning to the end. Okay, so it is the wavelength. Okay. Okay. So it's also known as distance between any two successive point on the wave from one point to another point on the wave. So it is known as wavelength. Okay. Okay, so the unit is in millimeter. And it depends on the frequency and also the propagation speed of the EM radiation lah. So this is the formula or the equations for this wavelength. Okay. So biasa you biasa dengar tak C equal to F lambda. Biasa dengar tak equation tu? Ataupun V equal to F lambda. Okay. So it is the basic equation lah. Okay. So kalau you biasa dengar kan, C equal to F lambda. Okay, so from that equation, so you boleh tahu dia punya wavelength, dia punya frequency, okay, and their correlation, okay. So the wavelength depend on the frequency and the propagation space, okay. So let's say the frequency increase, frequency of the EM radiation increase. So what happened to the wavelength? Okay. So let's say a frequency increase. So what happened to the wavelength? Is it increase or decrease? Siapa? Hasnita ada tak?
Ada, Doktor.
Okay. Okay, Hasnita. Let's say frequency increase. Frequency of the EM radiation increase. So what happened to the wavelength? Is it increase or decrease?
Increase.
Are you sure?
Decrease. Decrease.
You tengok dia punya equations tu kan? Okay,
Berkurang.
kalau frequency tu increase, so apa jadi pada dia punya wavelength?
Berkurang.
Wavelength will decrease because dia it is proportional, apa nama tu, it is inversely proportional to the wavelength frequency. Wavelength inversely proportional to the frequency. So kalau frequency tu increase, wavelength akan decrease lah. Okay. Okay, so what about amplitude? What is amplitude? Anyone? What is amplitude? Siapa eh? Fahda ada tak? Fahda Nur Humaira. What is amplitude? What is amplitude? Any idea about amplitude? What is amplitude? Kita tengok graf ni kan? Okay. What is amplitude? Syaiful, ada tak? Syaiful Fazli. Okay, Syaiful Fazli. Apa amplitude Amplitude tu apa?
Pada kefahaman saya, amplitude tu macam peak of wave.
Okay.
Yeah.
Peak. Okay. Alright. Ada lagi tak? Pak Istiqmal ada tak? Ada ke tak ada? Pak Istiqmal? Ni Pak Istiqmal ni. Siapa lagi ya? Farhan. Farhan ada tak? Farhan ada ni. Dah. Farhan dah ke? Dia sebut nama tamu panggil.
Ya, ada doktor.
Okay, Farhan. What is amplitude, Farhan?
Saya tahu amplitude tu apa, tapi nak terang ni susah ni.
Tak apa, awak terang je bahasa yang awak faham, tak apa.
Okey. Boleh doktor pergi semula ke graf tadi?
Okay. Okay.
Okey. Amplitude ni macam lengkung yang tertinggi daripada kosong tu.
Okay. So it is the maximum peak, betul tak?
Ya, macam tu lah.
Okay. So betul lah. Okay. Macam tu lah ya. Okay. So betul lah ya. So tadi ada kata peak, ada kata apa lagi tadi ya? So basically betul lah. So kita tengok graf tu, the highest peak tu adalah amplitude lah, the maximum displacement of the particle of pressure wave. Okay, so it is the amplitude. Okay, this one lah. Okay, amplitude, the highest point. Okay, the maximum displacement of the particle. So it is amplitude. Okay, so normally dia graph tu, the sinusoidal graph. Okay, so it is between amplitude and this direction of the wave travel. So amplitude tu, apa awak panggil? Y-axis lah. Okay, it is amplitude. The maximum displacement, maximum peak. Okay, next frequency. What is frequency? Akmal sekali lagi. Okay, Akmal. What is frequency, Akmal?
Frekuensi ya tu. Frekuensi tu dia satu direction kot.
Direction.
Dia satu rate,
Kalau you tak boleh explain, you boleh on you punya video, you boleh tunjuklah macam mana bentuk tu. Okay.
Oh, kalau buka video macam tak terbentuk lagi.
Oh, tak terbentuk dah. Okay. Pula dah. Okay, tak apalah. Siapa lagi ya? Martin ke? Apa nak panggil apa ni? Martin is your father or your name?
My father's.
Oh, sorry. Oh, so your name is? So
Max.
I should call you Max. Okay, Max. So what is frequency?
Frekuensi ni macam ni. Dia 1/1 time. I mean 1/2 second.
1/2 second. So let's say I said frequency, it is number of cycle per second. Is it correct?
What?
Number of cycle per second. Is it correct or not?
Yes.
Okay. So frequency, it is number of the cycle, number of the wave per second. Okay?
Okay.
Okay, so correct lah. You said that frequency is 1/t, right? Okay, so it is correct. This is the unit for the frequency. Cycle per second. One cycle per second. The unit is hertz. Okay. Okay, wait. Sekejap. Okay, so this is the equation for the frequency. It is 1/period. Okay, or 1/t lah. Okay. Or also, frequency can be represented by the V equal to lambda. Okay. So let's say we have high frequency and low frequency. Which one have the highest wavelength? High frequency or low frequency? Okay. Anyone? High frequency and low frequency. Yang mana mempunyai wavelength atau lambda yang paling panjang? paling panjang lah.
Low frequency.
Cuba buat. Low frequency and high frequency. Which one have the highest lambda or the longest the longest wavelength? The highest wavelength.
Low frequency.
Low frequency. Okay, correct. Okay. So you kena ingat this, you must remember this equation lah. Okay, because this equation you can correlate between the frequency of the EM radiation and their wavelength. Okay. So for the longest wavelength, they will have low frequency. Okay, means that they have low number of cycle per second. Low number of cycle per unit time. Okay. Understand, yeah? Okay. Okay, period. Period of T. Okay, so what is it? T. Any volunteer? Any volunteer? What is period for electromagnetic radiation?
Doctor, how about one complete cycle?
Who is that? Akmal eh?
Hisham.
Hisham, sorry. Hisham. Okay. Apa Hisham? Again Hisham?
One complete cycle. It's a period.
Okay. It is time required for one complete cycle. Okay, tadi nampak kan? The S wave tu kan? Okay. So, period it is refers to the time to complete one cycle. Okay. Inilah yang tadi tu. Macam ni. Sorry. Okay, this one. To complete, time to complete one cycle. It is period for the electromagnetic radiation. Okay. Okay, and it is reciprocal with the frequency. Frequency equal to 1 over T or 1 over period, and period equal to 1 over frequency lah. So this is their equations. So whenever you increase the frequency, you will decrease the period to complete one cycle. Okay. So this is their equation. And velocity. Okay, so for EM radiations, whenever they travel in the space, they travel at the speed of light. Okay, this lah. Okay, so this is the equation lah between speed, wavelength and frequency. V equal to F lambda. So this is the basic equation yang you kena ingat lah. Okay, so from this equation, you will have your, you will know the wavelength, the frequency of the EM radiation. Okay, and okay, so this is the equation for the wave model or wave theory. Okay, V equal to F lambda. V equal to velocity or speed of light. Okay, and F frequency in hertz and wavelength in millimeter. Okay, and sometimes in meter or in centimeter. Okay, depends lah. Okay, but their unit is normally in millimeter. Okay. Anyone? Okay, answer this question first. You ada calculator tak? Okay, handphone pun boleh lah. Okay, kalau you ada, cuba you jawab soalan ni. Okay. Jawapan dia apa? Cuba baca dulu. Dah siap? Siapa yang dah siap boleh cuba jawab? Any volunteer? Siapa nak cuba jawab soalan ni? Jawapan ni berapa? How to calculate this question? Dah siap ke? Akmal dah, Akmal?
Siap tu, siap.
Okey Akmal, apa jawapan dia Akmal? Macam mana awak kira?
Saya dapat 17, lambda 17. Wavelength dah 17.
Okey. 17 apa tu? 17 apa?
17 mm.
11 mm. Okey, yang lain macam mana awak kira?
Ambil 340 tu bahagi dengan 20.
Bagi
Sebab
20.
340 tu sebagai apa? Velocity. Dan 20 tu sebagai frekuensi.
Okey. Siapa lagi? Sarina. Sarina.
Ya, saya.
Boleh kira, awak dah kira yang ni?
Sudah.
Okey, apa
Sama.
jawapan awak dapat?
17.
Okey, 17. Unit
juga.
dia apa?
Milimeter ke yang
Kilo
kilohertz tu nak tukar kepada hertz? Tak perlu juga kan?
Sepatutnya awak kena tukar lah. Sepatutnya awak kena tukar kepada kilo.
Kilo tukar kepada hertz saja.
Betul.
Jadi kena darab ke?
Nak
Bagi
tak awak kena buat lah. Awak guna equation yang mana? Which equation you use?
Sepatutnya kalau saya belajar dulu saya tukar hertz. Tapi saya lupa macam nak tukar hertz.
awak darab macam lain ni. Yang ni, okay, so
Darab 10.
untuk this question, so you kena tukar dulu 20 kilohertz ni kepada hertz lah.
Sekejap ya.
Okay, Zakwan, dah kira ke belum?
Jawapan saya macam Akmal,
Berapa tu macam Akmal tu?
17 mm.
So unit tu you kena sure unit berapa per unit yang dapat. Sebab kat situ 340 340 in meter per second kan? And in kilohertz. Okay. So you kena make sure lah berapa yang you dapat tu. Kadang jawapan tu betul dah. Tapi yang unit tu salah. Kat belakang tu. So you have to you kena make sure. So my answer is 0.017 meter. Okay, 0.017 meter. Okay, so you buat nanti lah. Okay, so make sure you kira betul lah. You kena tukar dulu. Because here this question, the unit for the the unit in meter kan. So you kena make sure lah. Betul, you tulis unit kat belakang tu. Okay, so the answer is 0.017 meter. Okay. Okay, next we move to particle model or particle theory. So whenever the high frequency electromagnetic radiation interact with metal, they behave like particle. Okay, no more wave lah. Okay, so this occur at high energy or high frequency. Okay, and this electromagnetic radiation, they act like a small bundle of energy, which is known as photon or quantum. Okay, so this is the properties for the particle model or particle theory. So this photon, they carry a specific amount of the energy and dependent on the frequency. Okay, and the photon energy and the frequency is it is proportional. Okay, let's say you increase the frequency, the energy also increase. Okay, so this is the equations for the particle model or particle theory. E equal to hf. Okay, so E equal to the photon energy, h which is Planck constant, and f equal to the photon frequency in hertz also lah. Okay, so E equal to hf. Okay, so Can you calculate this? What is the frequency of the of 72 keV X-ray photon? Okay, soalan simple je ni. Okay, frequency of the 72 keV X-ray photon. Okay, you dah tulis ke soalan dia? Have you write the question? Okay. 72 keV. Apa frekuensi dia? Okay, so you go back to this equation lah. Okay, so you use this equation to calculate the frequency of the photon energy. Okay, apa jawapan dia? Ada dah kira ke? Berapa jawapan yang dapat? Tadi 72 keV. Berapa jawapan dia? Dah siap ke belum? Vincent Wong. Is that your name? Your name Vincent Wong. Betul tak? Vincent Wong? Vincent.
Ya, saya.
Okay. What is the answer, Vincent?
Uh,
Have you calculated it?
Sudah aku kira.
Okay. So what is the answer, Vincent? Ini pun direct. It's just direct question. You have What is the answer? Anyone yang dah siap kira? Dah ke? Apa jawapan dia? Nur Aini. Dah kira ke?
Dah.
Apa jawapan dia?
Kalau mengarit, sorry
Kenapa?
Kalau mengarit, sorry.
Okay.
Saya dapat 1.735 Hz.
Okay. Tu aja.
Itu je.
Okay.
Tak tahu.
Okay, cuba cakap macam mana you kira? How you calculate it?
Sekejap.
Ah.
72 kilo. Apa tu? 72 tu saya tukarkan kepada apa EV tu? KEV tu kepada EV.
Okay.
Saya
EV
darabkan.
is electron volt.
Saya darabkan 1000. 72,000. Lepas tu buat macam biasalah.
Pasal cuba you guna equation ni macam mana? How you calculate? Cuba you explain how you calculate. Start from the equation here.
Saya masukkan nilai tu dekat dalam equation tu.
Okay. So kat sini kita nak cari frekuensi kan? So the equation become F equal to frequency equal to photon energy per F equal to Planck constant apa nama tu? Sekejap saya pun dah kena tulis dulu. You nak cari frekuensi, right? So F equal to Planck constant and divided by E lah kan?
Oh,
Betul tak?
Hmm.
Betul tak ni?
saya tak tahu.
Okay, macam mana?
Saya
Okay.
pening.
Oh, pening. Okay. Okay. Sekarang nak cari frekuensi. So macam mana you kira?
Macam tu lah.
Aduh, okay. Yang lain?
Okay.
Not so high lah. Okay, not so high lah. Your answer is correct. So how you calculate it?
So kan 72 keV tu kepada 72,000. Lepas tu bahagi dengan dia punya Planck's constant ni 4.15 kali 10 kuasa negatif 15. Saya dapat jawapan 1.73 kali 10 kuasa 19.
Okay. So how to find the frequency? The energy divided by the Planck constant, right? Betul tak? Is it correct? So frequency equal to E over H lah. E over H. Okay. So the photon energy you can tukar dulu kepada electron volt. Okay. And divided by the Planck constant kat sini. Okay. So the answer is 1.73 times 10 power 19. Okay. Okay, so you just masukkan saja value tu dalam equation ni lah. Nanti you akan dapat lah. Okay, so make sure kalau masa kelas fizik kan, make sure you ada calculator senang untuk you kira. Kalau handphone tu dia tak keluar number kat belakang tu kan. Dia punya apa nama yang number banyak kat belakang tu susah nak kira lah. So better you guna calculator lah. Okay, so the answer is 1.73 times 10 power 19. Okay, hertz. Okay, the unit is hertz. Okay. Okay, now we move to the electromagnetic spectrum. Okay, so the electromagnetic spectrum, it is like this. Okay, this is the famous lah. Biasa kalau you type je electromagnetic, so you akan keluar lah this spectrum. Okay, so this EM radiations they represent by this broad spectrum of energy magnitude. Okay, start from the longest wavelength to the shortest wavelength. Okay, so it start with radio wave. With the longest wavelength, and their shortest wavelength is gamma ray. Okay, so you must remember whenever the spectrum have the long wavelength, they have low frequency, they have low energy. Okay, but when the spectrum or when the EM radiation they have short wavelength, they have high frequency and high energy. Okay. Okay, so the longest wavelength is radio wave and the shortest wavelength is gamma ray. Okay, so you can see here, whenever you have a long wavelength like this lah, okay, you have short frequency, low frequency like this, low frequency. Okay. Whenever you have a short wavelength, you have high frequency. Okay, so their graph, their sine wave is high. Okay, for the shortest wavelength. Okay, for the longest wavelength, their frequency is very low. Okay, so you must remember lah the correlation between the wavelength and also the frequency. Okay, so we have radio wave, microwave, infrared, visible light, UV rays, ultraviolet rays, X-ray, and the gamma rays. Okay. So the shortest the wavelength, the higher the energy of the electromagnetic spectrum. Okay. And this electromagnetic spectrum, they can be classified into ionizing and also non-ionizing radiations. Depend on their frequency, their wavelength, and their energy. Okay, so you can see here, you can see in this spectrum. So which spectrum considered as ionizing and which part considered as non-ionizing? So you can see here. Okay. Okay, so for microwave, it is ionizing radiation or non-ionizing radiations? Zakwan ada tak? Zakwan ada? Zakwan, microwave is considered as ionizing radiation or non-ionizing radiation?
Tak silap saya ionizing doktor.
Awak tengok kat sini betul-betul.
Sekejap.
Okay, tengok kat sini. So this
Ah,
spectrum, you kena tahulah, okay? You must familiar with the spectrum because from this spectrum you can categorize the EM radiation. Which one is ionizing, which one is non-ionizing. Okay, so microwave considered as ionizing or non-ionizing? Microwave is
non-ionizing doktor.
non-ionizing radiation. Okay. Okay, so you can tahulah. So this EM radiation spectrum ni they classify the EM radiation tu. Which one is ionizing, which one is non-ionizing. So which one is harmful, which one is not harmful? Which of the spectrum is harmful and which of the spectrum is not harmful?
Ionizing is harmful.
Okay, give me example.
Gamma ray
Okay,
and X-ray.
okay. Siapa lagi? Tadi Fatihah kan? Nurul Izzati. Okay, Nurul Izzati. Which one is harmful? Which part of the electromagnetic spectrum is harmful to human? Give me example for the EM radiation that harmful. Sorry? Tak dengar lah. Sorry? Apa cakap?
Cosmic rays and ultraviolet.
Cosmic rays and ultraviolet. Okay. It is one type of ionizing radiation that harmful to the human lah. Okay. So normally the ionizing part, it is harmful to human. Okay. And meanwhile for non-ionizing radiation, it is not really harmful to human lah compared to ionizing radiations. Okay. Okay. So start with radio wave. Radio wave, it is also described as radio frequency or RF. Okay, in medical imaging you akan biasa dengar RF frequency, RF radio frequency. So it is refers to the radio wave. Okay, and it has the longest wavelength and lowest frequency and also lowest energy. And normally used in used for radio, for TV, for radar kan. You biasa dengar lah yang ni. And for radio, you biasa dengar AM frequency, FM frequency, okay. So all relate to the radio wave. Okay, they have the longest wavelength. Then microwave. Microwave, you biasa dengar juga. It have the shorter wavelength compared to the radio wave and higher frequency than radio wave, but lower frequency than infrared. And normally it's used for cooking, right? You biasa dengar kan? You biasa guna lah maksudnya. It is very common. Okay, so microwave, it is one kind of electromagnetic radiations. Okay, beside besides used for cooking purpose, it also used for the satellite communications. Okay, and also infrared. The next one is infrared, which have shorter wavelength than microwave. Okay, but higher frequency than microwave. Okay, and lower than red light of visible light. Okay, then infrared ni pun very common in medical field lah. Okay, normally used for thermogram. Okay. Okay, next one is visible light. So visible light, the only electromagnetic wave that you can see in terms of color, kan? Okay, so we see this wave as the color of the rainbow. Okay, so start with the long and violet. Okay, and each color they have different spectrum. Okay, and red color they have the longest wavelength. Meanwhile, the violet color they have the shortest wavelength. Okay. Okay, so you can see here lah. This visible light is cahaya nampak kan, yang kita boleh tengok lah. We as human can see the electromagnetic wave, the colors, okay, from the red and from the red color until violet color. Okay, and this color they have different range of the wavelength. Okay, and then UV rays. Okay, UV rays it is shorter wavelength and higher frequency than violet light. Okay, or the visible light lah. Okay, and it can be used. It has been used in health and also in agriculture field. Okay, so kalau you biasa dengar kan, baby yang ada jaundice kan, okay, so they use this kind of UV light lah, okay, to heal the jaundice disease. Okay, so for UV light, there are several category of the UV light or UV rays. Okay, so you can see here lah. So for this UV light, they have different wavelength. Okay, in terms of the type of UV rays. Okay, so they have far UV, they have UVC, UVB, and UVA or near UV. Okay, and as you can see from the spectrum here, right? This part of the UV can be classified as ionizing, and part of the UV can be classified as non-ionizing. Okay. So which one refers to which type of UV refers to the ionizing radiation? Okay, so we have several type of UV rays. Okay, so which type of them refers to the ionizing radiation? UVA, UVB, UVC, or far UV? So which one? Which one refers to the ionizing radiation? Anyone? Izatul. Which one? UVA. Okay. So cuba you ingat balik. Okay. For the ionizing radiation part, they have long wavelength or short wavelength. Okay, so go back to the spectrum again. Okay. For ionizing part, they have shortest wavelength or long wavelength. Okay, here. Okay, short wavelength, right? Okay. So they have short wavelength. So for ionizing part, they have short wavelength. So you can refer to the wavelength of the UV. Okay. So kat mana here? Kat mana kat sini Which type of UV ray have the or considered as ionizing radiation? Far or near UV? Far or near? Far or near UV. Yeah. Okay, siapa tu? Fatihah. Siapa? Izatul. Okay, so it is far UV lah. So far UV is classified as ionizing radiation. Okay. Okay, then X-rays. X-rays ni yang you belajar ni lah. Okay, it is X-ray. It is one part of the electromagnetic radiation spectrum. Okay, and these X-rays they have the shorter wavelength and higher frequency than UV ray. Okay, this is very common in medical field, in radiography field. So we use this X-ray to produce image, right? Okay, and X-rays they are absorbed by the test object, and they will appear white in the image. Okay, so you kan boleh nampak kat sini ni. So boleh tengok kat sini, the bone kan, the bone part normally appear as white. Why? Because the X-ray is absorbed by the dense object, by the solid object. Okay, so the image appear as white. Okay. So the next one is gamma rays. So gamma rays it has the shortest wavelength and the highest frequency, and it's very common also in medical field. Okay, and normally it used to kill the cancer cell, or also to image or to diagnose the disease. Okay, and this gamma rays normally used in nuclear medicine. Okay, meanwhile for X-rays it's normally used in diagnostic radiology. Okay, so you must know lah. Basically, their function are similar. Gamma rays can also be used to diagnose disease, similar to X-rays. You use the X-rays to produce image so that you can diagnose disease, right? But they have difference in terms of production. Okay, so for X-ray productions and for gamma rays productions, their production process are different. Okay. Okay. So anyone know the difference between gamma ray and X-ray? Any idea? Gamma ray productions and also X-ray productions. Any idea about the differences between gamma ray and X-ray? Okay, this one you use in radiography. Okay, this one you use in nuclear medicine. Okay, what about their productions? Apa yang beza dia? Because both of these can be used to diagnose disease. Any idea? Fahmi. Okay, Fahmi? Ada nak try jawab ke? Fahmi? Ke Fahmi tak ada?
Tak dapat dengar. Saya pergi toilet je tadi.
Oh, begitu. Okay. So, apa beza between gamma rays and X-rays? Because both of these have the shorter wavelength, higher frequency, kan? Ya, apa beza between gamma rays and X-rays?
The penetration for gamma ray is higher.
Okay. Lagi, Farhan. Apa beza Farhan between gamma ray and X-ray?
Saya pun tak tahu doktor.
Tak tahu. Tak apa, kita cuba Fahda pula. Fahda.
Gamma ray dia ionize dekat atom.
Aha. Okay, kalau you
dekat X-ray ionize dekat elektron.
okay, gamma ray.
Gamma ray ionize dekat atom kot.
Okay. Okay. Nur Aimi Atira kata, X-rays man-made, gamma rays from nucleus. Quote. Okay. Tak payah quote pun. Okay. So your answer is correct lah. So X-rays is coming from machine. Okay. So nanti you akan belajar dalam topik radiation interaction dengan Dr. Nazifah nantilah. So X-ray is coming from the machine, X-ray machine. Kan? You dah hands on ke? Ke belum? You dah hands on guna X-ray machine ke belum?
Dah doktor.
Dah. Okay. So X-ray is coming from the machine, from the X-ray tube. Okay. So means that X-ray are produced through the X-ray tube. Okay. Which is man-made lah. Okay. Meanwhile, gamma rays coming from radioactive source. Okay, so tu beza dia. Bendanya lebih kurang sama. Okay, both have shortest wavelength, high frequency, can penetrate human, okay, can produce image or picture, but their production are different. Gamma rays coming from the nucleus or radioactive source. Meanwhile, the X-rays coming from the X-ray machine or X-ray tube for the X-ray productions. So different lah. Okay. So they have different production. So tu yang beza je lah. Okay, basically dia penggunaan dia sama lah. Okay, so the last part is the applications of the EM radiations in radiography. And the most common EM radiation used for radiography is X-rays lah. Okay. Okay, so process of taking radiograph in medical imaging will result in emission of radiations. So what type of EM radiations produced during radiograph during chest X-ray? Okay, what types of EM radiation produced? Ini soalan bocor sebenarnya ni. Okay, kalau during chest X-ray, apa EM yang terhasil? Apa EM radiation yang terhasil? Akmal.
Saya kata.
During chest X-ray, apa EM radiation yang terhasil? Ini soalan bocor, saya kata ni soalan bocor. Apa yang terhasil? X-ray lah. Okay. During process of taking radiograph, you nak produce image kan? So, apa EM yang you guna for radiography? X-rays. Okay, X-rays. Okay. Nama pun just X-ray. Okay, so X-ray lah yang terhasil. So, you guna X-ray to produce image. Okay. Anda perlu membuka kunci iPhone Anda. Okay. Okay, so this X-ray pula ada banyak lagi. Okay. Ada banyak jenis X-ray ni. X-ray spectrum, they have branch halang, they have characteristic. Okay, so actually X-ray ni ada pula dia punya several part dia lah. Ada pula dia punya classification dia lah. Whether branch halang, whether characteristic, it depend on their production. Okay. Okay. Gamma rays, this one in diagnostic imaging. Okay, gamma rays can be used for imaging juga, but normally in nuclear medicine. Okay, used to produce image through the distribution of the radioactive source. Okay. Meanwhile, for the X-rays, these X-rays produced from the machine. Okay, which is outside the patients. Okay, gamma ray. For gamma ray, normally or the patients will injected with the radioactive source, so that the radiation is coming from the patient itself. Meanwhile, for the X-rays, the radiation or the X-rays coming from the machine. Okay, so here lah the difference between X-rays and gamma ray. Okay, so the gamma ray, the radiation coming from the patients. For the X-rays, the radiation coming from the machine. X-ray unit. Okay, this is the infrared radiations. Okay, so this infrared radiation, they use thermal imaging, okay, to produce thermogram. Okay, so this infrared radiation can also be used to diagnose patient lah. Okay, the part of the human body emit more infrared if they are hot due to the infection or injury. Okay, so you boleh nampak lah beza. You boleh nampak beza between the structures that have injury. Okay, so they have more, they emit more infrared compared to the normal tissue. Okay, visible light, this one used in the process for the image productions. Okay, in gamma ray or in X-ray productions. Okay, and another electromagnetic frequency that have been used in radiography is radio frequency or radio wave. Okay, normally it's used for MRI. Okay, so in MRI we didn't use X-rays or gamma rays, but we use radio frequency or radio wave to produce image. Okay, so it's different from the general X-ray. Okay, and another applications of the EM radiation used in radiography is laser. Okay, this laser can be used to cut, to burn or destroy the tissue. Okay, this one normally in actually this one in radiotherapy, in radiography tak begitu familiar lah, but in other medical field familiar. Biasanya kalau guna untuk yang yang mata tu, biasa dengar tak yang laser mata kan? Yang laser mata atau untuk apa panggil yang from Mahaya tu apa? Saya lupa dah apa nama dia. Ada ingat tak? Ada tak
Katarak.
ingat? Apa nama?
Katarak
Bukan kan, yang from Maya punya tu, yang untuk LASIK. Okay, LASIK. Ya, LASIK betul. The cure is LASIK. So dia guna laser. Okay, laser light lah to cut the itulah yang retina whatever tu lah. Okay, they use one kind of EM radiation, which is laser. Okay, and this laser, they produce visible, infrared, also UV rays. Okay, they use this lah, combination of this. Okay. Okay, and this are the other application of the laser. Okay, laser beam used to write information onto the film. Okay, kalau you pernah buat kan, for CRDR kan. Okay, so we use laser lah to produce the image on the film. Okay, and beside that, the laser also used for the aid positioning. For the radiation beam in radiotherapy, also in radiography lah. So kalau you nampak kan, dalam X-ray tube tu kan ada laser light kan, for positioning aid lah. So it is one kind of EM applications for the radiography. Okay, so that's all. Okay, so any question? Any question regarding our topic for today? Boleh faham tak? Kelas online ni macam tu lah. Dengar tak dengar macam tu lah. Okay, any question regarding our topic for today? Macam mana saya nak buat ni?
Doktor, saya ada soalan.
Ya.
Tak macam nak take untuk yang calculation yang first tadi yang kita buat tu kan? Kan kenapa dia punya ni meter kenapa tak milimeter?
Boleh juga. Kalau you nak tukar kepada meter, lain lah. You kena tukar daripada awal lagi. Daripada 340 meter per second, you kena tukar set kepada milimeter. Okay?
Okay.
Ah,
So kira kalau nak tukar kepada milimeter kena darab balik lah. So
iya, yes. Dia tak kira berapa pun jawapan you, yang penting unit tu betul. Kalau you change semua tu dalam milimeter, so you punya point tu akan berbeza lah. Betul tak? So dia jawapan tu akan sama je, 0 point something, tapi point tu akan berbeza, depend pada you represent your result in meter or in millimeter. Okay, sebab tadi question tu dia punya velocity kan in meter per second kan. So it just macam lagi senang lah. So you represent your result in meter. Okay, depends pada you punya velocity actually. Unit of velocity.
Thank you, Doktor.
Okay. So any more question? Actually saya nak buat kuis sebenarnya, tapi saya takut you all penat lah. You all okay lagi ke? Kat tengah hari ni? Ke dah ada habis tikong ni? Okay, so I give you link. So nanti you jawab apa nama tu, quiz ya. Boleh tak? Dengar tak? Sekejap, I cuba share dulu. Nanti you cuba buka. Boleh tak buka? Boleh buka tak? Link quiz. Link untuk quiz. Boleh buka? Okay, cuba. Kalau cuba